All right, we're going to talk about perpendicular and angle bisectors. So we're going to talk about perpendicular bisectors and angle bisectors. Okay. So the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay. So here CP is the perpendicular bisector of AB. So C is equidistant from A and B. Okay. So CA is equal to CB. The converse of the perpendicular bisector theorem, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment, okay? So if I know that CA is congruent to AB, A has to be on the perpendicular bisector, all right? All right, so CA is 6x minus 10, CB is 4x. I wanted to find the length of CB, okay? Well, so the first thing I'm going to do is I know CA has to be equal to CB. Why? Well, if I look at my diagram, AP is congruent to PB, so this is the bisector, CP is the bisector, and it's perpendicular. So now I know CA is equal to CB. And so now I'm going to go 6x minus 10 equals 4x. And I'm going to subtract my 4x over. So I have 2x minus 10 equals 0. Add my 10 over. 2x equals 10, or x equals 5. So now I have my value of x. But it doesn't tell me I want the value of x. I want the value of CB. So now I have to plug in. CB equals 4 times 5, or 20 units. Okay? So CB is 20 units long. All right. So example 2 is talking about constructing, given a visual diagram and constructing a perpendicular bisector. So we're going to refresh your memory on perpendicular bisectors. Okay, so here's my line segment AB. So if you remember your perpendicular line bisector, what we're going to do is we're going to take our compass. I'm going to use a string and a marker here, and we're going to open up that compass to where it's over half the distance to B. Okay, so it just has to be, and I'm going to make an arc here. And then I'm going to keep the same measurement on my compass. I'm going to make another arc there on B. Where these two arcs intersect, I'm going to connect them, and there's my perpendicular bisector. So this becomes C, we'll make this D and this E. So DE is the perpendicular bisector of AB. We did this back in one of the earlier chapters. Okay. Angle bisector. Okay, so angle bisector theorem. If a point is on the bisector of angle, then the point is equidistant from the sides of the angle. Okay, so here AB is, or AD is bisecting angle BAC. Okay, so now I know D is the same distance from side AB as it is from side AC. And we always measure distance perpendicular. Okay, so this is going to be a perpendicular angle on each of those sides there. Okay, the converse, if a point in the interior of an angle is equidistant from the sides of an angle, then the point is on the angle bisector. Now that I know that DB is the same as DC, I know that this is the angle bisector, okay, equidistance, okay, it has to be a right angle, has to be the same distance. Okay, so BD is 7x, CD is 2x plus 5, and I know, what is the length of BD? I know that this is the angle bisector. So that tells me that BD is equal to CD. And so now I'm going to have 7x equals 2x plus 25. I'm going to subtract off my 2x. 5x equals 25, or x equals 5. Once again, it's not asking for the value of x, but it's asking for the length of BD. So BD is equal to 7x, which equals 7 times 5, which is 35 units. Okay? So make sure you are finding what the question is asking for. Alright, so what do you get when you cross an elephant and a fish? Swimming trunks. What do you get when you cross an elephant with a kangaroo? Holes all over Australia. Okay, so make sure that you guys understand perpendicular bisector and angle bisector and how that relates within a triangle and how it relates to those endpoints and those sides of a triangle.